Okay, in this video, we're going to try to make two topics a little bit easier by combining them and letting you know that these two topics are actually the exact same thing, and that those two topics are linear functions and arithmetic sequences. They are the identical, exact same thing, with maybe one slight difference. Linear functions are linear functions are continuous. There's no breaks in between it. And arithmetic sequences are discrete, meaning that they jump from one term to the next term. So to determine if something is linear and arithmetic, here's all you need to know. There will be a consistent rate of change. It'll have a rate that never changes. What I mean by that is, notice that as your x values go up 1, your y values go up 4. As x goes up 1, y goes up 4. That's consistent. So that consistent rate of change we call slope, okay? The amount that your y's go up over the amount that your x's go up. Now notice here, though, that my y values go up 8, but my x values go up 2, and that is the exact same thing as 4 and 1. So therefore, if something's linear, it will have a consistent rate of change. That slope, we know if we're looking at the equation of a line, that slope is always located in front of your x. And by looking at a graph, we know that the graph will line a straight line. That's how you know if something's linear. Arithmetic, the exact same thing. You'll have a consistent rate of change. Notice my rate of change in this arithmetic sequence. I go up 4, I go up 4, I go up 4, I go up 4. That's what an arithmetic sequence is. The equation of an arithmetic sequence looks just like the equation of a line, except for we use a different notation. A sub n equals 2n plus 1. To where, again, there's our constant difference. And like I said before, arithmetic sequences are discrete, so therefore when you graph them, instead of having a continuous line, you'll have dots. The first term, the second term, the third term, the fourth term is 5, 9, 13, 17, and so on and so forth. Okay, now let me remind you how to find the equation of a line. And again, quick reminder that the equation line is always in this form, y equals mx plus b, where m is that constant rate of change, called your slope, and b is what's called your y-intercept. So in this problem, if they give you a slope, the easiest thing to do is just plug that slope in, y equals 3x plus b. And then in order to find that equation, we simply need to know where it crosses the y-intercept, what our y-intercept is. And in order to find that, we can simply plug in an x and a y that they give you. They give you a point. We know that this line has to satisfy that point, so we're going to plug in 4 for x, 7 for y. So my y is now 7. My x is now 4, and my advice is as you plug this in, why not go ahead and multiply that out? So 7 equals 12 plus b. Solve that equation, and you're going to know what b is. To move the 12 over, we're simply going to subtract it, and we get a negative 5 in the place of b. So therefore, you can simply just come up here where you had that b before, and your equation is now y equals 3x. 3 was the slope, and your b is a negative 5, so we plug it in. Y equals 3x minus 5. Okay, now what if you're given 2 points? This problem says we're going to pass on with the equation of a line, which again, equation of a line, y equals mx plus b, that passes through this point and this point. Now the only issue is they don't give us that slope. They don't give us that rate of change or a common difference if you're talking about an arithmetic sequence. We can very easily find it by doing y minus y, sometimes we call that delta y, over x minus x. Simply subtract y minus y in that order, the second minus first, or if the order doesn't matter as long as you keep it consistent. So negative 8 minus negative 2, which is negative 6, over x minus x, which is 2. And that's going to be your constant rate. You can reduce it, and that's going to be negative 3 over 1, or just negative 3. That's your slope. So it's going down 3 for every 1, is what that's saying. So we now have y equals negative 3x plus b. And again, in order to find that b, we simply plug in a point. It doesn't matter which one you plug in. What's nice about having 2 points, you could actually plug them both in and make sure you get the same answer. So we're going to have, I'm going to plug in the smallest one, 5, negative 2. So your y value is now negative 2. Your x value is now 5. When you plug it in, again, reminder, I would go ahead and multiply it out, negative 15 plus b. And again, we see that's going to tell us what b is. Move the 15 over by adding it, and we get a value of 13 for b. Come back up here where you nearly have the equation solved, and your line is y equals negative 3x plus your b value is 13. Okay, now let's talk about the equation of an arithmetic sequence. Quick reminder before we do that if we look at the graph of y equals 2x plus 1, again, this plus 1 is what's called the y-intercept. That's where that graph crosses the y-axis. The 2 right here, or 2 over 1, is your rate of change. The y goes up 2 for every x value of 1. So you can go up 2 over 1, up 2 over 1, up 2 over 1. And that's going to give you a graph. Again, the plus 1's where it crosses, and the 2 and 1 is the rate of change. If you know that, and we can very easily find the equation of an arithmetic sequence. Because again, let's look at the graph of this. Your first terms here is 3. And the way we graph arithmetic sequences, we come over, our first term is 3, our second term is 5, our third term is 7. And we simply plot those as the first term's 3, 1, 3, 2, 5, 3, 7, and so on and so forth. Well, in order to find the equation of an arithmetic sequence, and instead of using y, we usually use the notation a sub n or b sub n or c sub n, whatever letter we want to use. And we already know the slope. The slope is going to be the common difference. So since it's going up 2 each time, we can simply say 2n. Our slope is 2. We put it in front of the n. However, we don't know where it's going to cross. It's going to cross somewhere right in here. All we would have to do to find out, since this is the first term, and we need what's called the 0 term, we could simply go down in that pattern. Since we're going up by 2 each time, we can simply go down 2, and we see that our 0 term would be 1. That's going to be your y-intercept. So that's going to make it a whole lot easier to actually find these equations. So let's look at several of these and show you how quickly you can actually find the equation. So instead of y, we're going to put a sub n, or whatever letter you want to use. Our common difference is going to be our slope. So in this case, since we're going up 3 each time, our slope's going to be 3. And the term before this would be our y-intercept. So that's going to be, since we're going up 3 each time, we'd go down 3 and we'd get 4. That's going to be the equation. And again, we can always check this by plugging in. Like here, our fourth term. Our fourth term is 16, so if you plug in 4, you should get 16. 3 times 4 plus 4 is 16. The next one, your common difference. Notice you're going down each time. Down 2, so your common difference is now actually negative 2. And if you were to do the term before this, since you're going down 2, to get the terms after, go up 2 to get the term before, and that would be an 11. The last one, a sub n equals your common difference. You're going up 4 each time. If you were to go down 4, you would get a negative 7, and there's your equation. Okay, one last problem. What if we're given, in this problem, we're looking for the equation of this arithmetic sequence, but we're not given a common difference. We're not given the sequence. We're given a third term and a seventh term. That's the exact same thing as given 2 points. The third point is 10. The seventh point is 22. So in order to work this, you're going to have to find a common difference. The way we find a common difference is the difference in your y's over the difference in your x's. That's going to tell you the slope, or in this case, the common difference. The difference in your y's, 22 and 10, or you can do y's here, is going to be a difference of 12. The difference in your x's, 7 and 3, is going to be 4. So you have a common difference of 3. And you could actually write this sequence out, but you really don't have to. Because now you have a sub n equals 3n plus, and if you want to put b, since that's the letter we used a while ago, that's fine. And then you can plug in either point. So your y value is going to be 10. Your x value, or in this case n value, is going to be 3. As you plug it in, multiply it out, gives you 9 plus b. When you subtract 9, you get a b value of 1. Go back up here, and you can actually just erase it if you'd like to. Put in that b value of 1. There's your equation. And again, I recommend checking it. The seventh term should be 22. If you plug in 7, you do get 22.